I would like to talk about a simple design calculation, maybe our connection, and we have a single angle according to BS5950. Now, if we are told that we want to design an angle to carry a dead load of maybe 80 kilonewton and an imposed load of 35 kilonewton, and we are asked to use this grade 43 S275, the first thing we are going to do is we are going to get our design load, which is our factored load, 1.4 times 80 plus 1.6 times 35. This 1.4 is the factor of safety for the dead load, while this is the factor of safety for the imposed load. Now, if we do this, we get this. Having gotten this, which is what everybody can get, now how do we assume a cross section that we want to use? The first thing is that we have to increase this our load by 20% to find a cross section, and then we will now okay, maybe we want to use S275 steel or S355. Now, if you are using S275, our PY, our strength is 275 Newton per mm square. Newton per mm square for that. And our, what's it called? The under our steel table, we'll multiply this, we'll make this one, since we already know that strength is equal to force per unit area. So since we are applying 1.2 times the dead load and times the design load, then we'll divide by the AG. We'll make this AG, that's our area, the area of the section, to be decided to the formula, because this is what we can see in our steel table. So if we do that, we are going to arrive at this particular value. So we'll now go to our steel table and check for the area that is higher than that 7.33 centimeter square. Why I'm leaving it in centimeter square, because on the steel table we have it in centimeter square, so you won't be seeing it in millimeter square, so you have to convert to centimeter square. So that is, you divide by 100 to have this. So let's go and check on the table. So under our steel table, on equal angle, we have this is the area of the sections, and then we have 7.73 there. So here we are just going to, for this particular calculation, I'm taking this particular one, 9.38. I don't want to be so economical and be going for maybe 7.1. I think this one is okay for me. I don't want to be going to higher this thing. I'm going for this one, this 9.38. And if you look at it, it is area of section, and and we are dealing with unequal angle. So having done that, we go to the next phase, which is we are taking, this is the section we are trying now. So we are taking the gross area to be 938, because we have 9.38 centimeter square, which should be 938 millimeter square. So taking this, the bolts that we want to use, let's say we want to use 20 mm diameter bolt, and if we take the tolerance, it will make it, the hole will be 22 millimeter to allow the hole to enter easily. So if we do they will calculate our gross area of our connected element, which is equal to the 80 minus this 3.5, because we're taking this, let's say this the portion we want to calculate, 8 minus 3.5 times 7. So that's the area of the cross sectional area of this particular place. But we need to remove this O. So to get the ANI, which is the net area of connected elements, we'll deduct this O from it. Then we are going to have this one as the net area of the connected element. Having done this, then we'll now calculate this KE. This KE is gotten from our 5950 for when we are having S to be our steel number is S275. Its KE is 1.2. So this 1.2 we multiply with this, we have a value, which is this. Then this value is tested with our gross area of connected element to see if it is less than this one has to be less than this. If that is satisfied, then we now go to the area of the unconnected leg, which is just this area. This we got from the steel minus our area of connected element, which is this. So having done that, we just deduct this, then we have 402.5. Then the next thing is we calculate our AE, which is the summation of these plus this. So we have this plus this, we have it as 860. Then we now calculate our tensile capacity, which is PY to AE minus 0.582. This is in your PS5950. So we take the value out, Then we take the A2, we have it here, then we put the value there, then we check. Since this one is greater than our design load of 168, then it is safe. And under welded connection, since there's no bolt hole, we just look at the gross area, we take it, then we calculate the area of connected elements, we remove let's say this is where we are connecting the element, we just remove half of the thickness, then we multiply by the strength. So that means we are getting the area of this portion here like this. So, and the next thing is area of unconnected leg, which is this, which is 60 minus sorry, we can just remove this one from this, then we get this area of unconnected leg, which is 42.5. Then we calculate our tension capacity, which is AG minus 0.382. Mind you, our AG is the cross sectional area, which is 938 minus 0.3 times 82, which is this. We have it as 254 kilonewton, which is greater than 164 kilonewton. That means the structure is safe. Now, what it means is that even from here, from our observation, a welded connection is able to carry more strength than a bolted connection. Thank you for that.